Good evening once again. Today we are looking at measures of variability or measures of dispersion, or you can call them the spread of distribution. Now, uh, we are going to look at a few of them, although there could be a number of them. For example, we have the range, we have the mean deviation, we have the variance, we have the standard deviation, we have the coefficient of variation. All those measure the same thing. We have the z-scores. All these measure variability. They measure variability of observations from the measures of central tendencies or from the mean. However, in this recording, we are going to look at a few of them. We're going to look at the range, we're going to look at the variance, and we're going to look at standard deviation of both ungrouped data and grouped data. To what extent are the observations deviating away from the mean or deviating away from the measures of central tendency? This is what we are looking at under measures of variability. They help in decision making, in policy formulations, once you're aware of how your observations deviate from the measures of central tendency. Let's begin with the range. The range is the simplest of all the measures of variability. However, it may not be the best measure of variability to use, however simpler it may look. Um, Given the example or the previous examples that we had on ungrouped data and grouped frequency, they are the same examples I am going to use in measures of variability. The examples we used on measures of central tendencies, I am going to use those same examples in computing, in calculating the measures of variability. So let's begin with the range of ungrouped data. How do we find range of ungrouped data? This is the simplest because we look for the maximum out of the observations collected from the field, and then we subtract the smallest or the minimum observation. So in this case, our highest or our maximum observation was 25, and the minimum or the lowest observation was 28. So the difference of the maximum and the minimum gave us 17, and that was the range of ungrouped data, or the range of the class tests that we recorded in our previous example. Ungrouped data still, we're still looking at ungrouped data. The table before you has 3 columns, whereby the first column shows the observations. This I represents the observations, and from which number to which number. So xi is the observations. So we have observation 8, 9, 10, 12, 13, 16, 20, 21, and 25. And then the second column is the deviation of each observation from the mean. Remember, we computed our mean as 15.4. So we are subtracting 15.4 from each of these observations that you have, or that we have in our first column. So these in the second column represent the deviations from the mean. If we are to compute mean deviation of ungrouped data, we would only need these 2 columns. We would need the first column and the second column. So we would compute the sum, the absolute sum of all these deviations, and then divide by the number of the observations. So in this case, we would add all these observations in the second column regardless of the sign that is before them, and then we divide that number by the number of observations. That would give us what we call the mean deviation. It would give us the average deviation of each observation from the mean. However, if you want to compute the standard deviation and variance of ungrouped data, or ungrouped observations, then we'll go ahead to compute the third column. The third column is composed of x minus mean. Now, x is the observations, and then mean is the one that we had computed earlier on, the one that we got as 15.4. And then we square that. So when we square, we are trying to get rid of the negatives we had before. So after that, we find that the sum of the third column. So the sum of the third column is also divided by the number of observations. You may decide to divide that by n minus 1, or you can take n. However, the difference between those two answers will be minimum, will be very small. However, according to some sources, dividing the squared deviations by n minus 1 gives a better estimate of standard deviation and variance. So how do we get the standard deviation of ungrouped data? Standard deviation of ungrouped data. When you look at the formula that is before you, we have S. I am using S because the observations we collected were on sample based. If we had them on population based, then I would use sigma instead of S. So S is equal to the square root. I'm finding standard deviation of the observations of ungrouped data. So in this case, I'm looking at the square root of the sum of x minus x bar. That is not x, that is x minus x bar. So it's supposed to be x minus the mean into brackets squared. The squared deviations, or the sum of the squared deviations divided by n, or n minus 1. Now, I decided to divide by n, that's why you see 10. So if I had decided to divide by n minus 1, I would have 9. But the answer is very, very, very close to each other. Either way you choose to go about it. So the answer was 5.5. So on average, there are 5 deviations of the variability from the mean is 5. The greater standard deviation, the greater the variability. The smaller standard deviation, the smaller the variability from the mean, or the variability of the observations from the mean. The beauty about standard deviation and variance is you can estimate one and then one leads you to the other. Now, having computed our standard deviation, getting variance is just a walkover. We just have to square the standard deviation. Now, if we had computed our standard deviation on population basis, we would have sigma. So variance would be sigma squared. But since it is sample based, we are having S, statistic S. So the variance is equal to S squared. So I'm going to square the value I had for standard deviation, and that's what I got as 30.25. However, I can also first compute variance and then later on compute standard deviation. Grouped frequency. Looking at grouped frequency, we have more number of columns in our table, or on our table, compared to the number of columns we had under measures of central tendency. Remember, when we were computing measures of central tendency, we only had class intervals, we had frequencies, we had cumulative frequency, we had the midpoints, or you can call them class mark, then we had the effects. So that's where we had stopped. We did not go into the deviations because they were not needed. We were not looking for variability. We were looking for measures of central tendency. So on our table, we have included 3 more columns. We have the deviations from the of each observation. Remember, the observations are represented by X. They are represented by the class mark or midpoint. And then we subtract mean. the mean we got in under our measures of central tendency, and then the squared deviations, and then later on we have the frequency times the squared deviations. If you were looking for mean deviation of grouped data, then we would still end on this column. We would end on the column where we have x minus mean, and then we would find the absolute summation of all these values in this particular column, and we divide by the number of observations that we have. So we will divide the summation of the deviations from by 50, and that would give us the mean deviation. We add regardless of the sign when we are computing the mean deviation. So that you can also try that out in your free time and see what you will get. The beauty about this table, that having computed all that is necessary in this table, it will lead you to easier computations of the standard deviation, the variance, and all that you need, even the range. So how do we get range of grouped data? How do we get range of grouped data? Range of grouped data is gotten by subtracting the highest upper class limit minus the least or the lowest lower class limit. So in this case it will be 90 minus 10. However, some resources or sources, they can use class boundaries. Like I told you in our previous classes, if you collected data on continuous variables, then you will need a class boundary column. So on all the measures you're going to compute on these observations, you will find that instead of using the class limits, you will be using the class boundaries. So in case I had weights, in case I had heights, in case I had length or weight recorded as my observations, then I would go ahead to have a class boundary column. And in this case, I would subtract the highest upper class boundary minus the lowest lower class boundary to give me the range of grouped data. So how do we find the standard deviation? The standard deviation, we have the sum of the frequency times the squared deviations. The sum of the frequency times the squared deviations. And then we divide by the sum of the observations. But as I told you earlier on, you can also decide to have the sum of observations subtract 1 from that. That is still very true and is still very fine, depending on what you want, because either way the estimator will just deviate from each other by a very small margin. The answers will be close to each other. Whether you decide to subtract 1 from the sum of observations you have, or decide to take it as a whole, it will still give you answers close to each other. So when I took the sum of frequency and the square deviations times the square deviations, I got 14,778, and then I divide by 50 and got my standard deviation as 17.2. So on average we are saying the observations deviate away from the mean 17.2. So 17.2 shows the variability of the observations from the measure of central tendency, or from the mean. Now from the standard deviation, it is very easy to get variance. You just square the standard deviation and that gives you the variance. Either way, you can first compute the variance and then you get standard deviation. If you want to first compute the variance, then you would remove the square root from the formula. So your variance will be the sum of the product of frequency and the square deviations divided by the total frequency, or total frequency minus 1. It will still give you the same variance that you have got after after getting standard deviation and then squaring the value and leading you to variance. So either way, you still get the correct answer. Those are some of the measures of variability, or measures of dispersion, or measures of variability or dispersion or distribution. So they really help us in decision making. They help us to know how much or on average, how much do these observations deviate from the mean? Is it very far or is it very small? So it can help you to make informed decisions in business, or informed decisions in your day-to-day businesses, or in your day-to-day decisions. Thank you for listening.